Welcome back to Networks and Distributed Systems. This course is based upon the textbook by Jim Caros and Keith Ross, Computer Networking, a Top-Down Approach. The course is divided up into a number of modules, and we have already completed 3 of them. An overview module, a module on the application layer of the TCP/IP model, and a model on the transport layer of the TCP/IP model. So we've started at the top of the TCP/IP model and are working our way down. We learned in the previous unit that the transport layer provides various forms of process-to-process communication, relying on the network layer's host-to-host communication service. We also learned that the transport layer does so without any knowledge about how the network layer implements this service. In this module, we'll learn exactly how the network layer implements the host-to-host communication service. We'll see that unlike the transport and application layers, there is a piece of the network layer in every host and router in the network. The network layer is also one of the most complex layers in the protocol stack. We'll begin our study with an overview of the network layer and the services it can provide. We'll then examine 2 broad approaches towards structuring network layer packet delivery, the datagram and the virtual circuit model, and see the fundamental role that addressing plays in delivering a packet to the destination host. In this unit, we'll make an important distinction between forwarding and routing functions of the network layer. Forwarding involves the transfer of a packet from an incoming link to an outgoing link within the single router. Routing involves all of the network's routers whose collective interactions via routing protocols determines the path that the packets take on their trips from source to destination. We'll look at packet forwarding in the Internet, along with the Internet Protocol, or IP as most of us have come to know it. We'll investigate network layer addressing and the IPv4 datagram format. We'll then explore network address translation, abbreviated NAT, datagram fragmentation, and the Internet Control Message Protocol, ICMP, and also IP version 6. We'll then turn our attention to the network layer's routing function. We'll see that the job of a routing algorithm is to determine routes from senders to receivers. We'll first study the theory of routing algorithms, concentrating on the 2 most prevalent classes of algorithms, link state and distant vector algorithms. Since the complexity of routing algorithms grows considerably as the number of network routers increases, hierarchical routing approaches will also be of interest. We'll then see how theory is put into practice when we cover the Internet's intra-autonomous system routing protocols, RIP, OSPF, and ISIS, and its inter-autonomous system routing protocol, BGP. We'll close this module with a discussion of broadcast and multicast routing. We have a load of work to do on the topic of the network layer, so let's get started. Figure 4.1 shows a simple network with 2 hosts, H1 and H2, and several routers on the path between H1 and H2. Suppose that H1 is sending information to H2, and consider the role of the network layer in these hosts and in the intervening routers. The network layer in H1 takes segments from the transport layer in H1, encapsulates each segment into a datagram, which is the term we're using for the network layer packet, and then sends the datagram to its nearby router 1. At the receiving host, H2, the network layer receives the datagram from its nearby router R2, extracts the transport layer segments, and delivers the segments up to the transport layer at H2. Make a note, the primary role of the routers is to forward datagrams from input links to output links. Watch this. Note that the routers in Figure 4.1 are shown with a truncated protocol stack, that is, with no upper layers above the network layer. That's because, except for control purposes, routers do not run application and transport layer protocols such as those we examined in modules 2 and 3. The role of the network layer is simple. Move packets from a sending host to a receiving host. Sounds simple. To do so, two important network layer functions can be identified. The first is forwarding. When a packet arrives at the router's input link, the router must move the packet to the appropriate output link. For example, a packet arriving from host H1 to router R1 must be forwarded to the next router on a path to H2. The other function is routing. The network layer must determine the route or path taken by packets as they flow from sender to receiver. The algorithms that calculate these paths are referred to as routing algorithms. Algorithms that calculate these paths are referred to as routing algorithms. A routing algorithm would determine, for example, the path along which packets flow from H1 to H2. Forwarding refers to the router local action of transferring a packet from an input link interface to the appropriate output link interface. Routing refers to the network-wide process that determines the end-to-end path that packets take from source to destination. Obviously, in order to determine the best route to take from source to destination, it's necessary for the routers to know something about the paths. It would be like us having a map to a destination that we're planning to visit. Wouldn't it be nice if when we were looking at such a map we could tell which roads were under construction or even closed? Well, we'll soon find out that routers that do all this route planning can usually do just that. Not only know which routes to use for a datagram, but also what conditions exist along each path. Every router has a forwarding table. A router forwards a packet by examining the value of a field in the arriving packet's header, and then uses this header value to index into the router's forwarding table. The value stored in the forwarding table entry for that header indicates the router's outgoing link interface to which that packet is to be forwarded. Depending on the network layer protocol, the header value could be the destination address of the packet or an indication of the connection to which the packet belongs. In Figure 4.2, a packet with a header of 111 arrives to the router. The router indexes its forwarding table and determines that the output link for this packet is interface 2. The router then forwards the packet to interface 2. Let's discuss how forwarding tables in the routers are configured. This is a crucial issue, one that exposes the important interplay between routing and forwarding. As shown in Figure 4.2, the routing algorithm determines the values that are inserted into the router's forwarding tables. The routing algorithm may be centralized, with an algorithm executing on a central site and downloading routing information to each of the routers, or it could be decentralized, with a piece of the distributed routing algorithm running in each router. In either case, a router receives routing protocol messages, which are used to configure its forwarding table. Regarding terminology, we'll reserve the term packet switch to mean a general packet switching device that transfers a packet from input link interface to output link interface according to the value in a field in the header of the packet. Some packet switches are called link layer switches, base their forwarding decisions on values in fields of the link layer frame. These switches are then referred to as link layer devices. Link layer, by the way, is the layer below this one. Other packet switches, called routers, base their forwarding decision on the value in the network layer field. Routers are network layer 3 devices. But we must also implement layer 2 protocols as well, since layer 3 devices require the services of layer 2 to implement their layer 3 functionality. Since our focus in this unit is on the network layer, we'll use the term router in place of packet switch. We'll even use the term router when talking about packet switches in virtual circuit networks that we'll be talking about later. I think this is a good place to take a break. Go ahead and review your notes and update your study guide. And when you're ready to proceed on Lesson 2 of the network layer, come on back and we will continue.